Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about what are the most commonly used method that we can call on TreeMap data structure. So make sure to watch this video till the end. So without wasting any time, let's get started. Alright guys, let's begin this video. So first of all, I will show you 4 ways to create TreeMap data structure. So the first way to create TreeMap data structure is using void constructor. So let's call TreeMap, give it a name, TreeMap is equal to new TreeMap. Okay, so you can see here we are not passing anything to the TreeMap constructor. So that is why we call it void constructor. So let's add some key value pair to this TreeMap, tm.put. So give it 1 as a key and 1 as a value. Let's add few more key value pair. Okay, let's add 3 as a key and 3 as a value. Let's add 4. Let's add 5 as a key or 5 as a value. Now let's print this TreeMap on the screen. So let's print this TreeMap on the screen, system.out.println, give it a tm, run the program, and you will see that all the key value pair are arranged in ascending order of the keys, okay, that are 1, 3 and 5. Okay, now the second way of creating TreeMap data structure is using a comparator interface. So let's say we want to sort all the entries based on the decreasing order of the keys. Then we can pass a comparator in the constructor of the TreeMap. So let's use the existing predefined comparator that is available in collections class. So let's call collections dot reverse order. Again print this TreeMap on the screen and you will see that now all the entries are arranged in decreasing order of the keys 5, 3 and 1. So this was the second way of creating TreeMap data structure. Now the third way of creating TreeMap data structure is using the existing TreeMap. So let's create a new instance of TreeMap, tm2 is equal to new TreeMap. So let's pass the existing TreeMap in the constructor of this TreeMap. Okay, now let's print tm2 on the screen, run the program, and you will see that now tm2 has all the entries that are present in tm. So this was the third way of creating a TreeMap data structure. Now the fourth way of creating TreeMap data structure is from the instance of hashmap. So let's create a hashmap. Okay, give it a name, hashmap, and let's put all these key values in hashmap. Okay, now let's pass this hashmap in the constructor of the TreeMap. Okay, now let's run the program, and now you can see that this TreeMap has all the entries that was present in hashmap. So that is why 1, 3 and 5 is being printed on the screen. So these are the 4 ways of creating TreeMap data structure in Java. Now we will see all the most commonly used method that we can call on TreeMap. Okay, so let's begin. So let's create a new TreeMap. So give it a name, tm is equal to new TreeMap. Okay, let's add some key value pair into this TreeMap. So tm.put, give it a 1 as key and 1 as value. Let's add few more key value pair. 1, give it 3 as key, 3 as value. Give it 5 as key and 5 as value. And give it 7 as key and 7 as value. Let's print this TreeMap onto the screen, give it a tm, run the program, and you will see that all the entries is being printed on the screen based on the natural ordering of its key. Okay, 1, 3, 5 and 7. Now let's call the first method on this TreeMap data structure, that is first key, tm.firstKey. So first key returns the first key of the TreeMap, and that is 1. Okay, now let's call the next method, that is last key. So last key is going to print the last key of the TreeMap data structure, that is 7. Okay, because all the keys are arranged in natural ordering of the key, because all the entries are arranged in natural ordering of the keys. Okay, now the next method is headmap. So headmap method takes key as argument and returns map of all the entries whose key is less than equal to provided key. So let's give it 5. Okay, run the program, and you will see that all the entries whose key is less than 5 is being printed on the screen, 1 and 3. Now the next method is tailMap. Okay, so tailMap also takes key as argument. Now what this method does, it takes key as argument and returns map of all the entries whose key is greater than equal to the provided key. Now let's run the program and you will see that all the entries whose key is greater than equal to the provided key is being printed on the screen. Okay, so far so clear. Now let's see the next method, that is lower entry method. Lower entry, and this method also takes one argument as a key. So let's give it an argument. Let's give it 2. So this method takes key as argument and returns an entry whose key is less than the provided key. Let's run the program and you will see that the entry whose key is less than the provided key, that is 2, is being printed on the screen, and that is 1 and 1. Now let's see the next method, that is hierarchy. So hierarchy also takes a key as argument and it's going to return an entry whose key is greater than provided key. Let's run the program and you will see that the entry whose key is greater than the provided key, that is 3, is being printed on the screen. Now the next method we are going to see is floor entry. Okay, so floor entry also takes key as argument. Let's give it 4, and what this method does, it takes key as argument and in return it gives entry whose key is greatest but less than equal to this key. Okay, let's run the program and you will see that this is an entry between 1 to 7 whose key is greatest but less than the provided key, that is 4. Okay, so that is why 3 is being printed on the screen. Now let's see the next method, that is ceiling entry. Okay, so ceiling entry also takes a key as argument, and what it does, in return it gives us entry whose key is list but greater than equal to the provided key. Let's run the program and you will see that 5 is being printed on the screen, because from 1 to 5 the key that is list and greater than equal to 4 is 5. Okay, so guys, these are all the most commonly used method that we can call on TreeMap data structure. So guys, I have shown you all the examples using primitive data structure, that is 1, 3 and 5. But as we remember that all the collection classes works only on non-primitive data structure. So have you ever wondered how is it working? So guys, internally Java converts this primitive data structure into its wrapper classes. Okay, and this phenomenon is called autoboxing. So here the one is a primitive data type and the non-primitive counterpart of this one is integer class. Okay, integer. Okay, so that is why the Java internally converts this one into its counterpart, that is a non-primitive data structure. So how it's done internally? It simply calls integer dot value of 1. So this way our primitive one gets converted into non-primitive one, that whether TreeMap allows null entries or not. So let's put null here and give it a value 1. Run the program. Okay, before run, let's remove this piece of code here. Run the program and you will see that it is throwing an error, and that error is null pointer exception. Okay, this means null is not allowed in TreeMap data structure. If you pass null as a key, it will simply throw null pointer exception. And why is it so? Because in TreeMap all the key must implement comparable interface, but in case of null it is not possible to implement comparable interface, right? That is why it is throwing null pointer exception. Now let's see whether the heterogeneous objects are allowed in TreeMap or not. So let's give it a okay, as a key and 2 as a value. Let's run the program and boom, you will see that again it is throwing an exception, and that exception is class cast exception. And if you look at this exception, it is saying that integer cannot be cast to class java.lang.character. So this means heterogeneous objects are not allowed in TreeMap. We must provide all the keys belongs to same data type. Okay, if you are starting with integer, then you must be provide all the keys as integers. Okay, as soon as you provide a key that did not match with the previous data type, it will throw an exception, that is class cast exception. So only the homogeneous type of keys are allowed in TreeMap. So guys, I hope by now you have a solid understanding of TreeMap data structure and what is allowed in TreeMap data structure or not. So guys, by now I hope you have a good understanding of TreeMap data structure. Now you know what are the most commonly used method that you call on TreeMap data structure. Is null as a key allowed in TreeMap data structure or not? And last, whether the heterogeneous object as key is allowed in TreeMap data structure or not. So guys, this is all from my side. If you have learned something valuable from this video, then please hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.